Okay, good evening, guys. In this video, I'm going to be explaining to you how Ohm's law directly affects resistance. It is said that when voltage increases in Ohm's law, resistance decreases. So I'm going to be carrying out an experiment that will directly explain how voltage affects resistance. Okay, I'm going to use an LED. An LED. So I'm going to directly connect the one of the pins, which is the negative pin, so negative terminal of the source, and then for the positive pin I'm going to pass it through a 10k ohms resistor. This is a 10k ohms resistor. Through a 10k ohms resistor to positive terminal, and right now you see the light is on. And what is our voltage? This meter will give us our voltage reading currently. So right now we are operating. Okay, let me transfer the loop down here in order to be able to give us our voltage reading. So now you see on the meter 11.28 volts. Let's just call that 11 voltage. And you see the bulb is on and it's very bright. This is 10k ohms resistor. Now I'm going to reduce the voltage to about 5 volts. Let us see how bright the LED will be. So right now I'm reducing that as 9, 8, 7. You see the brightness of the bulb is reducing, and this is 5.3. You see the brightness of the bulb. So I'm going to take it down to 3 volts. This is 3.4 volts. And you have noticed that the brightness of the bulb have reduced. Now, Ohm's law states that the amount of current flowing through a circuit is directly proportional to voltage. So it means that for any material to conduct electricity, the voltage has to increase such that it's begin to force an electron through that material. When the voltage increases to a certain point where the resistance of that material stops, it should begin to force electrons through the material. Now see the brightness of this bulb at 10k ohms resistor. So I'm going to change it to 1k ohms resistor at 3.4 volts. Let's see the brightness. So at 3.4 volts, using 1k, you see the brightness. Compare this to the 10k at this same 3.3 volts. You see that the brightness, so for 3.3 volts, 1k ohms is a good conductor. And then for 3.3 volts, 10k ohm is a poor conductor. This is the same thing as using any other material like paper, stone, and any other material to uh, as a conductor in your circuit. So this is exactly what happened. This is exactly what Ohm's law is saying when it says voltage directly affects current and inversely affects resistance. Now let me show you. Even this LED on its own has a resistance, its own internal resistance, which can allow this LED to work very well. You see the brightness to work very well. This is at 3.3 volts. This is at 3 volts. See how bright the LED is. Now, if I start increasing the voltage, we get to a point where the LED, the material at which the LED is made up of, begin to act as a surge. Okay, now this is the reason why your electronic devices blow up when NEPA gives you high voltage. It is because when the voltage increases, it causes the components in the electronic system to the resistance of the components in the electronic system to decrease, resulting at surge. So as voltage increases, it gets to a point where the resistance of the electronic components in your electronic devices no more count. So at that point, they act as a surge. But since the supply voltage from the source is higher, that's the capacity of the supply voltage from the source is higher than the capacity of whatever is surging it or the electronic components in your electronic devices, it will end up burning your electronic devices. So this is why if I increase, continuously increase, this is 4 volt and the LED is already showing sign of uh, blowing off. So let's keep increasing. This 5, 6, 7. You see the LED has blown off. It has blown off at 7 volts. So it means at 7 volts, this LED is no more a device to the source. Instead, it is now a surge system to the source. That is how it works.